Hello everyone, this is Sahitya, Assistant Professor working in EC Department, MLR Institute of Technology, Hyderabad. We are discussing in the electronic devices and applications. In the last session, we already discussed about the different types of the rectifiers. So in the last session, we discussed about the how the half-wave rectifier will be formed and the half-wave rectifier operation, and later we discussed about the full-wave rectifier and bridge rectifier. Now, in the today's session, we have to see about the parameters of the half-wave rectifier. So, coming to the today's session, the contents are, we have to discuss about these parameters, the DC value or average value, and coming next one is RMS value, root mean square value. The third one is ripple factor and the efficiency. So, we have to calculate the efficiency of the rectifier, peak value, form factor and peak factor. So all these topics will be discussed in the today's sessions. So now we have to enter into the today's sessions. So here we are discussing about the half-wave rectifier. So what is meant by half-wave rectifier? So half-wave rectifier is a device which converts the AC to DC, By using the half-wave rectifier, we rectifies only one half cycle, that is either positive half cycle or negative half cycle. So what is the output of the half-wave rectifier? Means if you give the complete cycle, means that means it contains both positive half cycle and negative half cycle, the output will contains only either positive half cycle or negative half cycle. So here the output is present only for the one half cycle. Next, coming to the today's session, so first we have to discuss about the DC value or average value. So DC value, or it is also called as average value, or it is also called as mean value, or it is called as mean value. So it is also called as DC value or average value. So what is the output of the half-wave rectifier? Means it will rectifies only one half cycle. Total 2 pi radians, it will rectifies only half cycle, means it will rectifies only the one half cycle. Coming to the average value or DC value, it is denoted with the letter VDC. So here we are taking the output voltage VDC. So coming to the average value, how we will find the average value? Means, so we have to take the complete time. So what is the complete time here? 0 to 2 pi, and here we have to go for the, if you go, it is a discrete signal, then we have to go for the summation, but here it is a continuous signal, so here we have to go for the integration. So the time period will be ranges from 0 to t, and the output signal V naught of t into dt. So here what is the total time period for the one cycle? So one cycle will be repeats for, here every cycle will be repeats from 0 to 2 pi. So the total time period is equal to 0 to 2 pi, and the time period integration will be ranges from 0 to 2 pi. So what is the output here? V naught of t is equal to Vm into, where Vm is nothing but the amplitude, and this is in the form of sin omega t, where omega is nothing but the frequency, and Vm is nothing but the amplitude. So substitute that equation. So here V naught of t into dt. Okay. Now here the signal will be varies for the time period. So I am splitting this equation. So here the integration will be ranges from 0 to pi V naught of t plus integration of pi to 2 pi V naught of t into dt. Okay. Now see from that figure, we can note that what is the output for the 0 to 2 pi? For the 0 to 2 pi, the output is Vm into sin omega t into dt plus, and what is the output or what is the signal for pi to 2 pi? Pi to 2 pi is the signal amplitude is equal to 0. So it is equal to 0. Then 1 by 2 pi. Here Vm is nothing but the constant. Vm by 2 pi integration of sin omega t. Integration of sin omega t is nothing but cos omega t into dt. Cos omega t. Integration of sin omega t is nothing but cos omega t, and the limits will be ranges from 0 to pi. Vm by 2 pi. If you apply the limits, then what is the output? Cos pi. Cos pi is nothing but minus 1. And cos 0. Cos 0 is nothing but 1. But here it is a lower limit. So, minus 1. That is equal to Vm by 2 pi into minus, this value is equal to minus 2. Minus into minus plus, and these two is cancelled. So, therefore, output is equal to Vm by pi. The output DC voltage is equal to Vm by pi. Now, we have to calculate about the IDC value. So, IDC means VDC into RL. VDC by IR. So, IDC, current is equal to VDC by RL. What is the VDC value here? We already calculated the VDC value. What is the VDC value? Vm by pi into RL. So, Vm by RL. Vm by RL is nothing but the Im. Im by pi. That is the IDC value. And VDC value is, what is the VDC value? Vm by pi. So, this is the DC value of half-wave rectifier. That is the DC value of half-wave rectifier. And the next, we have to discuss about the root mean square value. So, root mean square value, RMS value. RMS value is nothing but the root mean square value. In the last, we discussed about the mean value. Now, we are discussing the root mean square value. So, mean value means which is used to calculate the DC value, and RMS value means it is nothing but the AC value. So, AC value. Now, we are calculating the RMS value. So, here also we have to calculate VRMS and IRMS. VRMS and IRMS. So, first we have to calculate the VRMS value. So, VRMS means, RMS means under root of the mean square value. Under root of mean square value. So, what is the mean value? What is meant by mean value? 1 by total time period integral of total time period x square of t, or V naught output whole square. Here we are discussing about the root mean square value. Mean is mean squared value. So, x square of t into dt. X square of t into dt. So, we already know what is the output of the half-wave rectifier. So, it rectifies only one half cycle, that is either positive half cycle or negative half cycle, 0 to pi, 2 pi. Okay. Now, here the complete time cycle. What is the complete of the time cycle? 1 by 2 pi integral of 0 to 2 pi V naught square of t into dt. Okay. Now, from this output, what we can return? V naught of t is equal to, what is the output? Vm into sin omega t. Vm into sin omega t. For which values? If t will be ranges from 0 to pi, and V naught of t is equal to 0. If t will be lies in between the pi to 2 pi. Pi to 2 pi. So, from this output, what we can return? Integral of 1 by 2 pi. Here we have to split the integration. So, if you split the integration means integral of 0 to pi V naught square of t into dt plus integral of 0 to 2 pi V naught square of t into dt. Integration of pi to 2 pi V naught square of t into dt. This is for that. Then we have to apply the output signal 1 by 2 pi under root of 1 by 2 pi. So what is the output of 0 to 2 pi? For the 0 to 2 pi, that is the Vm of sine omega t. So integral of 0 to pi. So here we are taking the V naught square of t. So if you apply the square, then the output will becomes Vm square sine square omega t dt plus integral of pi to 2 pi. So what is the output for the limits in where t will be ranges from the pi to 2 pi? It is 0. Therefore, it is equal to, if you take the constant value, here Vm is nothing but the constant value. So then Vm square by 2 pi into under root of 0 to 2 pi sine square theta. What is the value of sine square theta? Sine square theta can also be written as 1 plus 1 minus cos 2 theta by 2. 1 minus cos 2 theta by 2. So Vm square is equal to 1 minus cos 2 omega t by 2 into dt. Then it is equal to, so Vm square by, take the 2 as a constant value, or to take out 2 out of the integration, that is nothing but Vm square by 4 pi integral of, then we have to apply the integration of 1 to dt, and here integration will be ranges from 0 to pi and minus integration of 0 to pi cos 2 omega t into dt. Cos 2 omega t into dt. That is equal to under root of Vm square by 4 pi integral of 1 into dt, that is nothing but t, and we have to apply the limits means pi, and for the lower limit 0. Pi minus 0 is nothing but pi, and for the integration of cos theta is nothing but sin theta. So sin 2 omega t by 2 under limits of 0 to pi. So here if you apply the limits, then under root of, that is equal to Vm square by 4 pi into pi minus sin 2 pi. Sin 2 pi means 0 minus sin 0, 0. So that is equal to under root of Vm square by 4 pi into pi. Pi cancel. If you remove the root, then what is the value? Vm by 2. So what is the RMS voltage value? Vrms is equal to Vm by 2. That is the RMS value. Now we have to calculate about the IRMS. So what is the IRMS value? What is the relation between voltage and current? IRMS is equal to Vrms by RL. So Vrms is equal to, we know that Vm by 2 into RL. Vm by 2 into RL. Vm by R is nothing but Im by 2. So IRMS is equal to Im by 2. So this is the IRMS value and Vrms value. Next, we have to discuss about the ripple factors. So ripple factor means we have to find out the ripples. Coming to the rectifier, the rectifier output is not a pure DC value. It contains some ripples. So here we have to calculate the ripple factor. So ripple factor is denoted with the letter tau. It is the, what is coming to the definition of the ripple factor? It is the ratio of AC component to the AC component to DC component. It is the ratio of AC component to DC component. AC component to DC component. So coming to the AC component. So what is the AC component? So AC component is denoted as VR of RMS, and DC component is nothing but VDC value. VDC. RMS value and DC component. AC component and DC component. So RMS is equal to, it can be given as under root of V square RMS minus, what is meant by the AC value means V RMS square whole square minus V square DC. So a DC component is nothing but VDC value. Therefore the ripple factor tau is equal to under root of V square RMS minus V square DC by, what is the DC component value? VDC value. So if you apply the root on denominator, apply the square and root, then the denominator will becomes under root of V square RMS minus V square DC by V square DC. If you are here, I am applying the square and root for the denominator term. Then what is the equation? V square RMS by V square DC minus V square DC by V square DC. That is equal to under root of V square RMS by V square DC minus V square DC cancel. So V square RMS by V square DC minus 1. In the last slide we already discussed. What is the VRMS value? Vm by 2. And what is the VDC value? VDC value is nothing but Vm by 5. These two can be therefore ripple factor tau is equal to under root of, what is the value of V square RMS? V square RMS is nothing but Vm by 2 by, and what is the VDC value? VDC value is nothing but Vm by 5 minus 1. So Vm cancel under root of 5 by 2 minus 1. So if you calculate these values, then the ripple factor for the half-wave rectifier tau is equal to 1.21. So for the half-wave rectifier, it contains 1.21 ripples. So here this half-wave rectifier is not suitable for the applications. And the next, efficiency. So for every system we have to find out the efficiency, how it will be works. So here also we are finding the efficiency. So efficiency is denoted with the letter eta. So efficiency means we have to calculate the ratio of output to the input. So here efficiency we have to take in the terms of voltage or current. So here I am taking the efficiency in the terms of output power to the input power. So efficiency means it is the ratio of output power to input power. So what is the output power for the rectifier? The output power is nothing but the PDC value, DC. And what is the input here? We are giving the AC input. So PDC and PAC. So what is meant by PDC? So PDC means, so what is the relation between the power and current? Power and current is nothing but I square DC into RL. So here we are taking the resistance, the DC is taken at the output. So here we have to consider the load resistance RL. Next, coming to the AC power. What is the AC power? The AC power is dissipated across the diode. So here AC power means here we are taking at the input side. So for the input side, the AC power is delivered to the diode I square D. For the diode, what we have? The resistance. That resistance is nothing but the forward resistance. The forward resistance is very small. And the power delivered to the load I square L into RL. Means load is nothing but the I square DC. I square DC into RL. So AC power is equal to I square D into RF plus I square DC into RL. So AC power can be calculated. It is a combination of diode power and resistance, diode power and load power. The power which is dissipated across the load. Now, the efficiency eta is equal to I square DC into RL by I square D into RF plus I square DC into RL. So the AC, the current at the diode is nothing but the AC current. So here we have to take the IRMS value. I square RMS into RF plus I square, sorry, here also the RMS power only. AC power no, we are calculating. So I square, the power at the AC power is the combination of diode power and load resistance power. So diode power means it is the combination of I current and resistance. I square D into RF. And for that the load resistance, at the load resistance I square RMS into RL. So diode resistance means I square RMS into RF plus I square RMS into RL. Then I square DC into RL by I square RMS. If you take the common I square RMS, then what is the value? RF plus RL. That is equal to I square DC into RL. In the denominator also we have to take the common term of RL value. Then what is the value? 1 plus RF by RL. RL cancel. We know that the forward resistance is very small. The forward resistance is very small. So here if you calculate the forward resistance with the 1 plus, comparing to the 1, the forward resistance is a very small. So we have to neglect the RF value. Neglect the RF value. Then the efficiency eta is equal to I square DC by I square RMS. So what is the I square DC value? We already calculated the IDC value. So IDC value is nothing but IM by pi. I square M by pi and I square RMS. I square RMS means IRMS is nothing but IM by 2. So I square M by 4. Then I square M cancel. Therefore it is equal to 4 by 5. So if you calculate, then the efficiency is equal to 40.6%. Percentage of efficiency is equal to 40.6. So how it will be gets means? So here we are giving the complete cycle. Of this complete cycle, what is the output we are getting? Only the 50% of the cycle will be we are getting. The remaining 50% will not be rectified. So out of these 50%, it contains only the 40% of the DC value. So the remaining will be the ripples. So that's why this half-wave rectifier will not be used in any applications. The percentage will be less than 50. The efficiency is less than 50. So it is not used for the many applications. It is used only for the theoretical, and it is not also used in the experiments. And the next one is peak value. Peak value means here we have to discuss about the diode. Actually, the diode in the reverse bias, what is happening? If the voltage will be increases, when the voltage will be increases, the diode junction will also be increases. When the voltage will further increases, the junction will be destroyed. So here we have to discuss about that peak value. The diode can withstand without destroying the junction. So what is the input we are giving? Complete cycle. So complete cycle means the positive peak will be ranges from plus Vm and negative half cycle will be ranges from the minus Vm. In the negative half cycle, we are giving the minus Vm. So for that minus Vm, the diode can be withstand without destroying the junction. So that is nothing but the peak value. So peak value is equal to Vm. So minus Vm. So here the diode will goes into the reverse bias only in the negative half cycle. In the negative half cycle, the amplitude is equal to minus Vm. So that's why the peak value is equal to Vm. Next, form factor. So form factor means it is the ratio of RMS value by average value. Form factor. It is the ratio of RMS value by average value. So RMS value is nothing but Vm by 2 and average value is nothing but the Vm by 5. Vm cancel, that is equal to the 5 by 2. This is about the form factor. In this session, we discussed about the half-wave rectifier. In the next session, we have to discuss about the full-wave rectifier parameters. In the full-wave rectifier, we have the two types. The one is full-wave rectifier with center tap and without center tap. So in the next session, we have to discuss about the full-wave rectifier with center tap. Thank you.